you. All right. It's always special to be back here. I've been standing here for many times already. Just this morning, the Uber driver asked me, "Is your first time in Amsterdam?" I'm like, "No." But it's fresh and special every time, and especially when I saw so many hands rising up for people who just here for the first time. So absolutely amazing that we keep having so many new faces here every year. So appreciate it, and thank you for being here. So today, again, I'm going to be talking about State of Vue and Vite. So let's get right into it. Vue was created in February 2014. So 2025 now? So wow, 11 years old framework. Sounds like a really, really old framework in JS land. But you know, it's amazing that the community is still strong, it's still growing, and we're seeing new things coming out from the ecosystem, from the framework itself. So some brief numbers, Vue today in numbers. We are over 10,000 plus commits across Vue 2 and Vue 3, including the work in progress branches. We have made over 500 plus releases over the 11 years, 2 million plus users worldwide, 250,000 plus GitHub stars, 6.4 million weekly NPM downloads, and 1 billion plus monthly CDN requests. So thank you for all supporting Vue and keep it growing for all this time. And looking at the numbers, the overall number is plus 35% compared to last year. Vue 3's usage actually increased by almost 70%. And overall, the total download numbers across all Vue versions, Vue 3 now takes up about 70%, and that number keeps growing. In September 2024, which is the current latest release, minor release, was 3.5. So in 3.5, we brought more reactivity efficiency improvements. So this has been a recurring theme in every minor release. Since 3.4, we did a reactivity refactoring in 3.4, we did another one in 3.5, and there is yet another one coming in 3.6. We stabilized reactive prop state structure and added a bunch of quality of life improvements, like use template rev. We improved SSR with lazy hydration, built-in use ID, and improved web components interop with defined custom elements. We also released DevTools v7 in October. So this has been a major improvement because the DevTools itself is now written in Vue 3. Up until that point, in fact, the DevTools v6 was using Vue 2 to support Vue 3. So in v7, we finally fixed that, and better performance overall. And a huge shout out to the developer, WebThans, please, that's his ID, for working on this. So now let's talk about what's coming in 3.6. So 3.6 has been in the works for quite a while. It's taking a long time because the main goal of it is to ship a reusable version of Vapor Mode. And Vapor Mode, which we will talk a lot more about in details later, is a big chunk of work. So we'll talk about more details later. So we still have something we need to finish for Vapor Mode to be generally usable. So please bear with us, but that is the major goal in 3.6. And like I mentioned, there will be even more reactivity improvements based on alien signals by Johnson, who is also the author of Volar and our Vue language tool. Johnson is also working on defined component type refactors to make component libraries to be able to generate leaner, smaller DTS type definitions, which will help with the bundle size, the distributed NPM package size of those libraries, and also help Vue language tools to be able to do the type checking a bit faster. And also, there's good news because TypeScript team just announced they're rewriting the TypeScript TSC in Go, which will be 10 times faster, and we're actively looking at how we can leverage that to integrate it with Volar. It's still very, very early because they haven't really implement the JS-oriented APIs in the Go version yet, but we've been in touch with the TS team. Actually, we knew this was happening last year, so we want to make sure the Vue language support is the first one to leverage anything that the Go version offers. And we are also going to move Vue's own build infra from the current setup over to Rodan and OXC, which is fully Rust powered. And we'll take a look at how fast that can become. So, alien signals, many of you probably haven't heard about it before. So, in fact, what is signals, right? Signals is a concept that in recent, maybe in the last 2 to 3 years, has been popularized by solid.js, but fundamentally, signals is the reactivity primitive, very, very similar to the shallow refs in Vue. So if you've used refs in Vue, you know what a signal is, right? It's basically something that contains a reactive value and can be tracked for reactive effects. So we have seen a rise of adoption of signals across different frameworks, like Vue being one of the earliest ones to go this sort of tracking-based reactivity route in the framework world. But in recent years, because of solid.js being very, advocating signals a lot, we're actually seeing adoption of signals in Preact, in Angular, Svelte 5 moved to signals too. So we're actually seeing React being the only framework that's not using signals as point, and there has been work at the TC39 level to try to standardize signals as a JavaScript language feature that will be implemented by engines, so we can leverage native performance. But before that happens, right, TC39 proposals take a very, very long time. It's usually slow-moving, takes years to find the landing actual browsers. So before that, there are polyfills. So Johnson started looking at signals, and he had some needs for a reactivity library for his own use in Volar. He felt Vue's reactivity system is too all-encompassing. It's too many APIs for his very simple use case. So he started working on a signal library of his own. And turns out he then went into the rabbit hole of optimizing it, benchmarking it, comparing it to other signal implementations, and ended up creating the fastest implementation of them all. So this is a benchmark comparing alien signals versus other implementations. So as you can see, Vue's current reactivity system actually isn't performing super well in this benchmark. And the TC39 signals polyfill, which is based on Angular signals, is actually really slow. So Johnson actually was able to re-implement the polyfill using alien signals to make it as fast as possible. And this was a relatively early screenshot. So Johnson wasn't really done there, so he kept pushing the boundaries and shipped in every new release of alien signals, it just got faster and faster and get more and more memory efficient. So 0.6, there's another 13.4 performance improvement. And in 1.0 release of alien signals, we can compare it to the early versions. Just every version, there's some sort of new optimizations that Johnson unlocked. And all of this actually lands in Vue 3.6. Because in 3.6, we have a version of Vue's reactivity system that's being refactored to be using the algorithms found in alien signals. And the nice part is, so this is alien signals 1.0 versus Vue 3.4's reactivity system. The purple bar is the baseline, which is the alien signal time, and the green bar is how long it takes for Vue 3.4's reactivity system. So the port has already landed in Vue's in development 3.6 branch. And the nice part for end users is there are no high-level API changes. It's all internal. You don't need to change anything. It just gets faster and more memory efficient and passes all ecosystem CI, so we believe it shouldn't affect any in-production usage. So things just get faster. And let's now talk about vapor mode. So where are we in terms of vapor mode? So I want to do a quick recap for those who are not familiar with the concept. Vapor mode is something we have been talking about for a very long time, but again, it's a huge undertaking because you're essentially reinventing the framework. We are basically re-implementing the whole framework with a different runtime and different compilation strategy. So we're basically having a new runtime package, runtime vapor, a new compiler, compiler vapor, and there are bits we can reuse, but all the features we need to reach parity. And because the focus is compatibility, we want to allow users to write the same source code with different compilation output, but also the same end behavior with better performance, right? So that's a lot of constraints and requirements that we have to work with. But This allows Vue users to keep using the familiar syntax and APIs that you use today without having to relearn anything new, but the framework just keeps getting better, and our rendering performance will be able to reach solid.js, which is kind of like the benchmark everyone uses as like the fastest framework nowadays, right? But as an 11-year-old framework, Vue has traditionally, people like no longer talks about Vue being like blazing fast, but Vapor Mode is essentially here to change that. So like I said, the biggest goal is we want to make it compatible with existing code bases. So initially, Vapor Mode will support a subset of today's Vue features. So if you use a single file component with composition API with script setup, we cover most of the same APIs, probably 95% at this point. But it will not be 100% compatible if you're using, for example, virtual DOM libraries. So we allow piecemeal migration without forcing you to rewrite your entire app. You can opt into Vapor Mode at a component level. So you can have just part of your app, which is probably performance sensitive, to be running in Vapor Mode, and you can also kind of control the exposure or the risk of such a migration. And then you can slowly migrate more and more parts of your app over to Vapor. So to give you an idea, on the left we have a single file component. This is the hello world that you see when you open the Vue SFC playground. Very simple. We have a single ref, and we have a text binding, and we have a Vue model on an input. On the right, this is the current output, the virtual DOM-based compiler. It compiles something what we call a virtual DOM render function, which looks quite complicated, but in essence, its function calls to create a virtual DOM tree and return it. Most of the work actually happens after this render function is called. All it does is just creating the data structure. The heavy work actually happens at the runtime, where we have the virtual DOM diffing engine to look at a previous copy of the virtual DOM and the next copy of the virtual DOM and to try to compare them. Right? So there's a lot of runtime code involved that's not in this screenshot. Whereas in this screenshot, what you see is the Vapor compiler output. It looks smaller. Actually, we omitted the part where the T0 and T1 are what we call template functions that just generates a piece of DOM using a string. So I missed out. I didn't include the part that shows what T0 and T1 looks like. But the idea here is Vapor compiler output. So T0 actually creates this H1 tag. T1 creates this input tag. X0 is what gets a hold of this text node inside H1. And then we have it applies the text model. Then we apply what we call a render effect that takes message.value and applies to this text node, right? Very similar to the code you'd write manually by hand. If you were to use jQuery to do something like this, you'll basically be saying, document create H1, create input, get the text node, and then set up a reactive effect that always sets it to the message value, right? So Vapor compiler output is basically trying to automatically generate the code that you would write, optimized code you would write manually, as close as possible. And most of the work actually directly happens here. When you call this function, the rendering, the bindings, everything is already set up and done. Compared to the virtual DOM render functions, most of the work actually has to be figured out by the diffing engine. So this also allows Vapor's runtime to be much, much lighter. So for example, these helpers, like apply text model, render effect, those are all really lightweight. We don't have to implement a complicated algorithm to walk through virtual DOM trees and compare these things. But the compiler does get a bit more complicated. So this follows along Vue's rendering strategy evolution. So if you've been using Vue in the very, very early days, like in 1.0 days, Vue 1 actually used what we call DOM-based templating. What it did is when you write templates in Vue 1, Vue actually instantiates the whole template as real DOM tree and walk the DOM tree and find the bindings and just mutate the DOM in place. In 2.0, we migrated to, we re-implemented into a virtual DOM-based approach. In 3.0, we added a more capable compiler to generate more optimized virtual DOM render functions. And in 3.6, Vapor mode is essentially what, the next evolution of what Vue's compilation and rendering strategy will be. Okay, so we've been talking about Vapor mode for a long time. In fact, since probably mid last year, we got it. It's being worked on mostly by some of our team members, including XZZ, Kevin, and a few other contributors. So they got Vapor mode to a usable mode. Most work has been happening on the compiler side. But when we come to the performance optimizations, most of the work happened in Q3, Q4 last year. So the progress since then, first of all, we drastically optimized component instance cost. Right? We re-implemented how Vapor components handle props and slots. So now they are lazy computed. We're able to mount 100,000 component instances in 100 milliseconds. That's on my, granted it's on my M2 Pro and MacBook Pro, but still I think that's quite impressive. We also refactored the whole thing for maximum reuse of runtime core logic between virtual DOM and Vapor. So internally now we have a shared generic instance type. So there are Vapor component instances and VDOM component instances. They are different, but they have a significant overlap in the types that we can essentially reuse logic for lifecycle hooks, error handling, provide, inject. All of these things will work together. This is also critical because eventually we want to allow a Vue app to contain a mixed graph of Vapor and virtual DOM components. So you can use Vapor in the virtual DOM component, and then it may be using another virtual DOM component. Right? If you want maximum performance, obviously you'd want everything to be in Vapor, but we realize in practice, you probably either have legacy code that you cannot easily just change everything to run on Vapor, or you might be using a third-party component library that's just hard-coded using virtual DOM. Right? So we want to support all those use cases. The nice thing here is because of the reuse, when we opt into Vapor mode in a virtual DOM app, let's say today you have a Vue 3 app, and you take one part, maybe one page of your application, you say, let's turn this into Vapor mode. The baseline size only increases by 3.5 kilobytes. Most of the large core logic is actually reused. So that's a very negligible increase on the total bundle size when you opt into Vapor mode, even within an existing VDOM app. And of course, if you use Vapor mode only, the baseline size is around like 10 kilobytes for an entire app. So we also fine-tune the performance. So this is probably the most exciting part because now we are actually beating solid.js and Svelte 5 in JS Framework benchmark. So this is probably the framework that everyone looks at when we talk about how fast is your framework, right? And in the past, we're not even showing Vue 3 and React in this graph because they're like, you can see the weighted geometric mean of Vapor is 1.07. I think Vue 2 is around like 1.25 probably, and React is like 1.4, 1.5. So there are variations when we run this benchmark. So in most cases, the number between Solid, Svelte 5, and Vue Vapor will be very, very close. It fluctuates a bit, but they're all on the same level now. So this is based on the work in progress branch, which we haven't published yet. So if you go to the JS Framework benchmark, there is an entry of Vue Vapor that's currently listed. It's based on a very, very outdated version, so that number doesn't count. We'll update that when we have a final release in 3.6. And the nice thing is we're actually not doing any benchmark-specific optimizations. For example, solid.js is really, really fast in this select role benchmark here. And you can see both Vapor and Svelte is relatively slow in this one. This is actually because vanilla.js uses imperative DOM manipulation. So when you select a single item in a really, really long list, it's just one line of code. But when you write declarative templates, we still have to loop through the whole thing to figure out which one is selected. Solid actually kind of cheats a little bit by using something called create selector. That's an optimization that's basically specifically just for optimizing this specific entry in the benchmark. We can do something similar, but we choose not to because we still beat solid in this case without even doing it. And another important thing, like I said, is Virtual DOM Vapor two-way interop, right? Running an embedded Vapor tree inside Virtual DOM is relatively easy. Doing the opposite is slightly harder. Allowing them to be nested indefinitely, having a whole mixed graph, is very difficult. Somehow we did it, and the props and slots are all working as expected now. So I was actually surprised I was able to get this working. I expected it to take much longer, but somehow it's working now. I think there will definitely be edge cases when we throw production code bases at it. So do expect this to take some time to stabilize, but basic two-way interop is actually in the branch now. So right now, the focus, there are two work in progress parts for Vapor mode. One is SSR hydration, right? So if you have a Nux app or you have something like VitePress website, you need hydration, you need server-side rendering. The good news here is we are able to reuse the exact same server render output across Virtual DOM and Vapor mode. So the server rendering part doesn't change at all. We do have a different compilation strategy when you compile a component for server-side rendering. So that part is actually consistent across Vapor and Virtual DOM. So both the runtimes will be able to hydrate from the same server output. And we got basic cases working already. But we do need a few more tweaks and tests to cover some of the edge cases. And then there's work in progress of the transition component. This is also largely working. It's now working with vif, vshow, has like in, out, and out in modes. But again, we need to write more tests and then try it in some real cases and see how stable it is. But both of these are making really good progress, and we should have them completed in the next month or so. And finally, some of the rest to-dos are async components. We don't expect this to be super complicated. The complexity probably is how async components work with hydration, but they should not be more complicated than the Virtual DOM counterparts. And then we have other built-in components, keep alive, suspense. Suspense will probably be the last piece for Vapor mode. But keep alive should be relatively straightforward. So we'll tackle that after the transition part is done. So how do we get access to Vapor mode in 3.6? So when 3.6 is released, you upgrade your Vue dependencies. Nothing changes if you don't do anything. But you can start opting into Vapor mode per component using script Vapor or script setup Vapor. You can omit setup because Vapor assumes you're using script setup. And you can create a Vapor-only app with the new Create Vapor App API. So when you create a Vapor app, it actually requires the whole app to be Vapor-only. This allows you to drop the entire Virtual DOM runtime from your code. So the bundle will be much smaller. The downside of this is if you use a third-party dependency like Vuetify, which is Virtual DOM-based, you won't be able to run those in a pure Vapor app. So you will have to use a traditional Virtual DOM app, but you can mount your root as a Vapor app and then only use Virtual DOM dependencies. That also works. Features likely won't be supporting 3.6 yet because we don't want to block it for too long, is keep alive suspense. OK, so we're also going to, in 3.6, we're going to be shipping Vue itself being bundled by Rowdown and all the TypeScript transformed by OXC. So in terms of how much faster that is, so here's a basic comparison. In 3.2, that's like quite a few versions ago, we were using a really old setup where we're using Rollup with the TypeScript plugin, which goes through TypeScript itself, plus Cursor, which is a JavaScript-based minifier. Then we use TypeScript TSC itself to generate the definition files, use API extractor for bundling. That whole process takes almost 2 minutes. That was painful. I remember those days, right? So in 3.5, I was like, I've had enough of this. I want to refactor it. So we migrated to Rollup plugin ES build using SWC for minify and everything. And that got us much better, almost around like 8.5 seconds. which is today how the code base is built. So I essentially, every time when I'm trying to make sure everything is properly rebuilt, I run build, and I will sit there and wait for 8 seconds. Okay, still annoying, right? So in 3.6, we're going to use Rodon and OXC. And that whole thing, including type generation and bundling, takes around 1 second. In fact, I think when I did this benchmark, we're still using a separate minifier, OXC minifier through a plugin. So I think today, if I use the latest version of Rodon with the built-in OXC minifier, it should take less than a second. So that's much, much better, right? I don't even need caching anymore. I can just like rebuild the whole thing every time I want to, and it'll still be fast enough. Okay, so there's also the upcoming Vue Language Tools 3.0. Johnson is already working on a preview of version of it. The focus of Vue 3 is really instability. So we know, when we released Language Tools 2.0, the main goal was to get rid of the hybrid mode, use a single instance of language server to make things more efficient, but it also brought a bunch of stability issues, mostly because we're using some pretty cutting-edge APIs, and VS Code and TypeScript, there's so many moving pieces, so things can just get stuck or get broken from time to time. So the focus of V3 is really improve the stability, making sure when you open files, it's always properly working. And there's, looking in the horizon, we are probably also going to be looking at how the Go version of TypeScript can make the whole type checking experience of Vue components much better. Okay, and then there's this interesting thing. So TikTok recently open sourced a project called Lynx. Lynx is this kind of like React Native, but it's actually framework agnostic. TikTok has been using it internally for years, and probably 4 to 5 years now. And they just recently open sourced it, and people have been asking for Vue support in Lynx. So Vue team doesn't really have the bandwidth to take on this whole thing. So on X, I was essentially saying, hey, if anyone wants to work on this, we'd be happy to help and give you pointers and making sure you can get what you need. Lynx team is actually open to this idea as well. So Hux, I actually know him personally for a very long time friend. He's now essentially kind of like the public project lead for Lynx, and they actually had this idea in mind. So so they are really open to collaborate with the Vue community to make this happen. And then someone just started working on it, and they already have some prototype that's kind of working. I look at the code; it's not properly using the custom render API yet, but I think it's very promising because we can see from the working in progress branch that Lynx is actually designed to be framework agnostic, unlike React Native, which is like really just React only, right? Lynx is actually, we are able to do, potentially have something like Vue Native running on top of it. And the cool thing is, people in the community have been saying that actually, the Vue SFC syntax may be better fitted for something for this purpose, because when you look at, say, Lynx code, inside the React code, because it's all JavaScript and JSX, they have to use something called like use main thread, a directive, to basically tell you, hey, this function needs to run in the main thread, and this function needs to run in the background. But it's all mixed in the same file. So the mental overhead of trying to determine which function runs in which thread in a native context is quite overwhelming. Whereas in the screenshot here, people have proposed a syntax where, SFC, because we have script blocks, we can just use separate script blocks to determine where the code should run. Right? It's very natural. And a lot of people are really interested in seeing this in action, because they do feel like, look at this. This is actually really nice if you want to have high-performance mobile applications implemented using web technologies. But at the same time, you have concepts that's, it's necessary to ensure high performance. You want to separate the computation between the main thread and the background threads. OK, so that's it about Vue. I think Vapor Mode and potentially Vue Native will be really exciting to watch in 2025. And let's talk about Vite. and also the work we've been doing at VoidZero. So the big picture here is Vite being the centerpiece that we're seeing in the past few years. It started in the Vue community, right? But we made it framework agnostic, and we now see almost every meta framework in the market except Next.js. So Next.js is the only one not on the hype train, but everyone else has jumped on the Vite hype train. So Remix moved over to Vite. Angular uses Vite in the step server. Actually, Angular team is interested in looking at Rowdown for potentially, use Rowdown in their build pipelines. And alongside Vite, we also have Vite-Test, which is quickly replacing Jest as the de facto test runner for Vite applications. And I think a lot of people are using Vite-Test even if they're not using Vite, right? Because it's just that good. For example, I think Lynx's repo actually uses Vite-Test. And then we have, so underneath Vite, what we're working on in VoidZero is mostly OXC and Rowdown, right? So these are relatively lower level. The goal of OXC is really to have this unified and standardized pipeline, lower level utilities, like all the way from the parser to transformer, minifier, resolver, these things that we typically need not just in a single place, right? Because think about it. Your bundler needs a parser. Your unit test runner needs a parser. Your linter needs a parser. And if you look at your stack nowadays, ESLint has its own parser, has its own ASD format. Rollup uses a different parser with a different ASD format. ESBuild has its own parser with a different ASD format. So today in our stack, we have all these fragmented pieces of tooling that all have to kind of do the same thing, like parse, get an AST, transform, generate code, but they're just not working with one another. It's like black boxes. So you let one tool handle this, it pipes out a big chunk of string, pass it into another thing, and it's inefficient. There are inconsistencies. You have to configure different things repeatedly for the same thing, the same things. It would be nice, and the goal of this whole endeavor is we want to have a unified system to handle all of these things. So we use the same ASD format, the same parser, the same module resolution logic, the same transformer, so that you configure everything once. For example, having Vite configuration as your source of truth, and everything else just works, right? You no longer need to worry about ESLint not understanding some custom things you did in your build config. You no longer need to worry about your test runner doesn't understand the aliases you've configured in your bundler. They should all just understand each other and work together. And that's the vision we're working towards. Right? So the progress here, OXC, we've already completed the parser, the linter, the resolver, the transformer. The minifier is also already usable. We're already having better compression ratio than ESBuild and actually being significantly faster. And the only missing piece really is the formatter, which we'll tackle just a bit later. Rowdown, we released Rowdown beta at the end of last year. And at this point, Rowdown is already at feature parity with Rollup and ESBuild, with slightly more. For example, we have Webpack-style advanced chunk splitting control, which neither of these bundlers have. And compared to Rollup, we have all these built-in features that ESBuild offers, like define, inject, built-in node modules resolution, so you don't need to use plugins for these things. They're all just running on the Rust side, blazing fast. So the focus right now is to get Rowdown integrated into Vite. So the current integration is unbundled mode, so it doesn't change how Vite works today. It's strictly replacing ESBuild and Rollup with Rowdown. And the focus is really compatibility and stability, because we want everyone running on Vite today to be able to switch over to the Rowdown-powered Vite without having to change anything. You'll probably want to optimize a few of the plugins you're using, if you're using really, really customized plugins. But in most cases, we expect, especially single-page applications, to be able to just switch over very smoothly. Ecosystem CI is at 95%. This means we are putting Rowdown-powered Vite into frameworks built on top of Vite and running their tests. And we have like 26 such integrations. Only 2 of them are failing at this point. And finally, we have Vite full bundle mode. This is currently work in progress. The key here is bundled HMR and incremental build. And we'll talk a bit about why we want to do full bundle mode a bit later. But this is what Vite looks like now. We have a JavaScript core, and then we rely on ESBuild and rollup for different things. ESBuild is used in dev, rollup is used in prod, and they have slight inconsistencies, differences. Rollup is relatively slow. And then some React users also use SWC because they want something faster than Babel. It's a mess, right? So this is Rollout Vite, which will soon release versions people can use. We unify everything underneath with Rollout indirectly powered by OXC so that we have consistent handling of all the tasks using the same stack. And then, in the future, the full bundle mode of Vite, Rollout will essentially take over a bit more responsibility, take it into the responsibility of the bundler, so that Vite's JavaScript side, well, the APIs, the parts that really needs flexibility, will still be implemented in TypeScript, but more and more responsibility will shift to the Rust side, and it will also be consistent between dev and prod. Okay, so why full bundle mode? This is mostly because we have, as Vite grew bigger and bigger and more users using it, we start to have enterprise users who have projects that's like 5,000 unbundled modules up front when they load the page. And loading so many modules over native ESM just incurs a lot of network bottleneck. It's actually not a bottleneck on the Vite side, it's just the browser is not able to handle that many requests. We've tried multiple different ways to circumvent this, but it's just very difficult. So we decided full bundle mode is really the only way to properly fix this once and for all. And also, full bundle mode gives you better dev prod consistency. So you're running the same bundle as close as possible. And because we want to do this, because our production bundle is ESM-based, so we actually invented a new HMR implementation. So it's based on HMR bundles, but it's different from how Webpack does it, different from how, actually Webpack is probably the only one that does it. But it's a brand new format that we basically created just for this purpose. So you'll be able to use Vite for developing your application, building an application, and also bundling your libraries, and they'll be all using the same ESM format output. And simpler custom SSR as well, because we will be able to get rid of the SSR externals and just bundle everything for consistency. OK, so the rollout plan for Rollout Vite. Currently, like I said, we're passing 90 to 95%, I think. We're at 95% now. So the phase one is we will publish it under a separate package called Rollout Vite on NPM. This is so that we can make this package have its own semver, so that you can use semver to control how you want to bump it. If we put it under the same Vite package, under something like a tag or something like that, then it loses its own semver, so it's kind of risky for you to just bump it randomly. The way to opt in is essentially use your package manager to just override, basically point Vite to Rollout Vite, and you're done. This also works for frameworks. If you're using a framework that uses Vite indirectly, so Vite is not in your root level dependencies, you can also use this method. Phase two is we'll switch over the Vite main package over to the Rollout-powered version, right? And then that version will also give you opt-in to full bundle mode. And phase three, we will eventually shift over to full bundle mode by default. So this will happen. So phase two and phase three, when do they happen? Will entirely depend on how stable and compatible they are, right? Our foremost priority is to ensure all these migration steps happen as smoothly as possible for end users, as little disruptions to your production workflow as possible. So we'll be carefully testing these out with early releases, with early adopters, making sure we catch all the edge cases through ecosystem CI before we make formal switches. And finally, this is something further down on the roadmap, what we call Vite Plus. So if you've used a language like Rust, how many of you have written Rust or played around with it? Not many, but when you use Rust, or when you try to learn Rust, the first thing you probably hear or see is like, they will make you use a thing called cargo. Cargo comes with a bunch of commands. Cargo can basically let you build, compile, test, link, bench, all the things you can think about developing in Rust. Cargo gives you a command for it. JavaScript never had that kind of experience, right? We're just so used to, when we try to think about the whole workflow of JavaScript, we're just so used to pick and choose and put together like dozens of NPM dependencies to cover all the little things we need. We want to change that, and V+ is essentially what we envision as the cargo for JavaScript. We want to put together these individual things that's currently handled by different packages and give you a coherent and streamlined experience under one single entry point. So this is obviously a much larger endeavor, which is what VoidZero will be focusing on for the rest of 2025. And we hope we can get a version of this to be usable in your hands by the end of 2025. So please stay tuned. And that's it. Thank you. OK. So before I get off the stage, there is one more thing. Is Matthias here? Matthias? Wait, I think we planned something here, right? No? He's not here? On Friday? Oh, God. OK, this is all messed up. But OK. But we do have a exciting thing. I'll just keep the suspense here then, right? So stay tuned for Friday. There will be something that we announce on Friday and something interesting to show you by then. So, all right, thank you, everyone.